That will have really good audio now. Sorry for that. To 32 dot or 64.128.256 or 512. So yeah, nothing too important there. In this example, device R1 is in AS 64500 and is connected to both device R2 and device R3, which are in 64501. This example shows the configuration on device R1. All right, so they're just going to show me on device R1, and then it's up to me to fill it in for the rest. So here it is. I think I should already have just about everything. Let's do a show configuration protocols, BGP, pipe display set relative. So, oh, it looks like I got extra stuff because I've got trace options enabled. So I will, I'll just get rid of those for now because I want it to look a little bit cleaner. Be nice if you could do like because yeah, it's nice to have trace options, but it's not nice to have them coloring up your config. So it's nice if you could do like a show configuration, no trace options, or like pipe no trace or something. That would be really nice. I guess there probably is a way to do that. Aha, yeah, because you could do pipe except trace options. Oh, and then pipe display set. Yeah. Now you can get everything. So if I go over to router 2 and do a monitor stop, so if I want to have nice, clean, beautiful output, I can do show configuration pipe display set pipe except trace options, and now I can see everything nice and pretty. Whereas if I hadn't included that, now I got to stare at all this extra config that's not going to be relevant to resolving my issue. So yeah, it's a little bit extra typing, but I consider myself a pretty competent typer. Whoever's watching this might not agree with me with all the mistakes I make, but just basically my point is that I'd rather trade off some extra keystrokes for having a kind of more power during the test to see what the issues might be. All right, so let's go back here and let's add that back in because I want to get used to having those tools at my disposal during the test. So I don't want it to be I want it to be something that I'm not comfortable using. So yeah, so let's go in and then we're going to need to add multipath. So edit protocols. Group. Oh, and looks like they went with a different group name than I did. I'll stick to my own and I'll set multipath. I'll look at the help menu first. So it says allow load sharing among multiple BGP paths. Let's do a help topic BGP and see if we can get help for multipath. Ah, we can, perfect. So, oh, and look at this. It's the exact same documentation we're looking at now. You get all of this during the tests. Really, really nice. You know, this is why I'm sticking to this because it's all going to be there for me during the test. Really nice and convenient. All right, but let's continue. I believe I actually configured that. I'll double check. Oops, show pipe display set relative. Pipe except trace options. Yep, so everything looks good. Oh, but it is missing multipath. Yeah, another thing I can do in secure CRT is set up custom hotkeys, and I can set up a show pipe display set relative pipe accept trace options hotkey and just push it whenever I want to do that. And another thing I could do, since it runs on Python, is take a look at the prompt here, and then if it's a $, then I'm going to do show pipe display set. But if it's a chevron, I'm going to do show configuration pipe display set. Because if I were to enter show pipe display set as I do when it's a $, it would not be very happy with me. But with that show configuration, there's no issue at all. So definitely a huge advantage of Python. It might even be worth secure CRT, might even be worth the extra minute or two to help me set that up. But definitely, at the very least, I can even just set up 2 hotkeys. I know how to set up hotkeys. I use it at work all the time, so it won't be hard. And then I believe you do get a free evaluation of PuTTY. Secure CRT. So it's like 60 days or something like that. So 60 days before the test, I'll be downloading that and using that here. All right. So yep, now we're going to need the policy statement, and then we'll need to export that policy statement to the forwarding table. And this is what allows it to actually do the load balancing. But of course, I get this in the help. So okay, so we've only got one statement in here, so we won't need to be thinking about the value of the walk-up knob. You can see set from route filter that's interesting. Okay, well, I don't see where walk-up would be entered, but I'll just continue with this and maybe look at that later. Okay, but I've got that statement in there, so time for the next one. All right, so time to export it into the forwarding table. All right, so that's all it needs. Let me do a show pipe compare because, yeah, so yep, everything looks good. So there's the step-by-step. It looks like yeah, and this is just so hopefully we'll have some nice verification commands. So yeah, here we go. Verifying routes, verifying forwarding. So let's go ahead with those. Hopefully I can finish this here shortly. So yep, now we've got our cost equal cost paths here. So it shows up there twice because they're equal cost paths. So but this is through our IGP. It looks like it picked the IGP over BGP. So unfortunately, we're really not getting the the output that this is expecting us to get. I have a feeling it's because we're exporting we're exporting our IGP. I don't think we need to do that, especially not in this topology, which is just a 3-router ring topology. So I'm gonna remove that. Configure private, show pipe display set, pipe accept, trace options. So let's see here. Pipe match, export. So export load balancing. Aha, so I don't think we're gonna need this in there. So let's remove that, and hopefully our results will look more like what they need to, will match the expected results in the documentation. All right, so now hopefully we're on the same page. Nope, we're still not on the same page. So it's picking the ISIS route to this destination over the BGP route. And that makes a lot of sense because this value here, administrative distance, is lower than that. So of course it's going to pick that over that. There's nothing we can do. It has nothing to do with whether or not it's exported. What we need to do is figure out why they, so they did tell you to export your, they did tell you to export your IGP routes into BGP. Yeah, so I'm not sure how they're expecting. So they want this route 10.0.2.0 to be learned from BGP. So let's trace out to that. Right now it's learned through ISIS. Let's think about how that route can be learned through only BGP and not ISIS. I mean, I think we can, oh, you know what? So, yeah. So I'm gonna roll back that change. And then I'm going to configure ISIS in a way that I think is more what they intend here, because if we're configuring an IGP, it's interior, it's an interior gateway protocol. So we would not be having adjacencies between devices in different autonomous systems. So I'm just going to sever those adjacencies. I'm not going to include those interfaces in there. So yeah. So none of these need, I mean, this doesn't even require an IGP. So you know what? I'm just going to wipe the whole IGP from this because it's in its own AS. There's no reason for it to have an IGP. So I will get rid of the IGP. All right, and now I actually don't need this statement anymore because I don't even have it. Perfect. So now I don't have that IGP. I'm still going to, let's see here, 10.0.2.0. Aha, so now I've got the output that we're expecting. I'm going to trim this up because there's no reason for it to have the interface facing R1 advertised into ISIS, or at least not as an active interface. So if there's a mechanism like OSPF, then I would like, aha, yeah, so, yep, passive. So there's a mechanism just like, yep, so there's no sense in running it because the other side it's not meant to have an adjacency with, but that network does need to be known by other routers in the same area. Yeah, and I can do the same thing for the loopback interface, I think. I'll just leave it off though. And that'll clear off chatter on the link if we pulled up Wireshark. Let's do that. I haven't. So let's pull up Wireshark here. We'll see some chatter on the link, and then I'll make that passive, and hopefully we'll see that chatter go away. That's kind of the importance of having those commands like the passive and stuff really well thought out and implemented. Otherwise, you get extra chatter in your link, and you're just wasting bandwidth and having degraded performance for no reason at all. And it won't degrade it much. I mean, of course, you're going to have this on a lot of your other links, but I think the worst case scenario is you'll be in a situation where you need to troubleshoot something, you pull up the Wireshark capture, and it's just all garbage. Like having a clean, tidy Wireshark capture is something I think is worth using passive commands and commands such as that. All right, let's see here. So, yep, so now we're going to do edit protocols ISIS, show pipe display set relative. We're going to do a run show int description to find the interface facing R1. It's going to be GE002. There we go. So now we're going to the interface, of course. All right. Oh. Okay, so now we can set it to a passive interface, and hopefully we'll see all those ISIS spamming things that aren't even relevant because there's no adjacency on that side are going to go away. So my ISIS adjacency to router 2 is no more. And we can see it's just filling up with those red BGP keep alives. And we've made the Wireshark capture a lot cleaner and nicer to look at. It looks like the capture might have stopped. Let's see here, show BGP. Oh, no, it's still going. Yeah, it's just nice and clean and tidy. So that's what we want. Okay, so hopefully these verification steps will go through. I kind of want to stop the video as soon as I can here. Yep, that looks good. So the meaning, the active path denoted with an asterisk has two next hops. Next hop here, next hop there. 10.0.1.1 and 10.0.0.2 to the 10.0.2.0 destination. The 10.0.1.1 next hop is copied from the inactive path to the active path. The show route detail command output designates one gateway as selected. Oh, I didn't see that. Where's that? Aha, here it is, selected. So it's the one to 10.0.0.2. This output is potentially confusing in the context of load balancing. The selected gateway is used for many purposes in addition to deciding which gateway to install into the kernel when Junos OS is not forming per packet load balancing. For instance, the ping MPLS command uses the selected gateway when sending packets. Multicast protocols use the selected gateway in some cases to determine the upstream interface. Therefore, even when Junos OS is forming per packet load balancing by way of a forwarding table policy, the selected gateway information is still required for other purposes. It is useful to display the selected gateway for troubleshooting purposes. Additionally, it is possible to use forwarding table policy to override what is installed into the kernel, for example, by using the install next hop action. In this case, the next hop gateway installed in the forwarding table might be a subset of the total gateways displayed in the show route command. So next step to verifying is to verify that both next hops are installed in the forwarding table. Yep, and sure enough, it looks like they are. So we've got the destination 10.0.2.0, and we've got 2.2 next hops, .1.1 and .0.1. Let's see if that's what we got here. 10.0.2.0, .1.1, .0.2. Yep, so everything looks great. Yeah, really easy peasy, nice and straightforward. We could do some more, let's see here, show log, BGP logs. Maybe just look at these a little bit, or maybe see if there's a multi-path in there. So type match multi. Aha, yeah, so there's a multi-path check. Yeah. So there's some interesting logs there. But let's see if there's anything regarding the next hop, 10.0.1.1. Oh, and right, this is going to be the neighbor address, so there's going to be all sorts of stuff, not just associated with the next hop. And then this is, of course, the router that is not getting everything. Yeah, so it's not doing it all. But I think this is enough for now. Kind of need a break. This video has been going kind of long, but we made all sorts of progress. So next video, we're going to be doing some more reading. It's going to be understanding configuration of up to 512 cost equal paths with optional consistent load balancing. and then we'll have one more lab. Hopefully we'll get all that done, and then we'll have finished the load balancing topic and can move on to the next one, scaling, and that's going to be huge because that's going to be route configurations and oh shoot, route reflection. So yeah, route configuration and route reflection in that one. But I don't know, multi-hop seemed kind of straightforward to me. It's just a knob that you toggle. I guess you do need to make that policy to actually enable it on a per packet basis and actually export it into a forwarding table. But there is a help topic BGP multipath example that makes it really easy. Yeah, so that whole step of having a policy to export it into the forwarding table, that's just spelled out right there if you know that help command. So yeah, I'm really not that concerned about this topic. So try to get through it as fast as I can. So that's the end of the video for today. Stay tuned for the next one. Thanks for watching.